Arun. So it is one of the best blogs I came across these days. So this talks about the major problem in the LLM industry right now, which is routing a request. So why a routing a request is important and what all factors will play. So we exactly don't know which model is best for which request. And since each model is cost a lot of amount, we would want to select the best model for for a given task. So, but a task by definition is not a single input query. So for a agentic systems and majorly the systems that we are interested are agentic, which can think, reason, and solve a problem. So for most of the agentic systems, a task is not as simple as a query. So it's a combination of queries, and it's a session with multiple prompts. So this block talks about how to manage the routing when we deal with sessions. So as a kind of I outlined, so there are multiple steps involved in a session and how a router should handle all the complexity and route to the best model possible. So as we know, prompt routing is kind of straightforward. We the automation code is simple. We have a prompt. Would like to route it to the best model possible. Here we can use various number of techniques, and here we can use ensembles. We can use symbolic routing, and we can like optimize the problem. But when the problem is a session, we are not really sure how to what is the scope of the session. So this blog outlines this same problem. So why singleton routing breaks down provisions. So let's say we have a user. We factor this model and run the test. So the prompt that if it's a prompt-based routing, the router will think, okay, it's a coding task. I would like try to assign it to a coding model. uh, the best coding model available out there. But the thing is, in this session, it might be using a model for a long time. So the entire cache will be on that model. So now routing this entire chart history to another model essentially makes us to calculate the entire cache again, which is not optimal. And when we switch models, there are dependencies on uh, the how each model behaves as well. So we'll go deeper into what those are. So the session state is really important. So in which part of session are we right now, and is it safe to switch the session? So there will be hard locks. So if we are in between a tool calling loop, switching a model will completely break the flow because the tool calls are based out of the current models in output, and the new model might not have the full context, and its tool calling might be completely different from what the current tool calling is. So it's best to lock the uh, tool calling loops with a fixed model. So for that, we need to have a clear idea of which part of session are we in, and uh, we need to have clear definition of boundaries. So when to actually switch a session is again a broad question. So if we are drifting from the conversation, it's fine if we switch the model. It doesn't make any sense. There are other scenarios when the user has left the current context and he came back after, let's say, 2 days. So there won't be any cache locality, anything. So in this case, we can like pick the best model out there because we are not we anyways we have to load the full thing again. Here we can take it as a new request itself, and if the conversation, let's say if the conversation is drifting, we would like to select the best possible out the model out there. So for this we need to reset the boundaries of the session. So the fourth one is whether switching is cost optimized or not. So this is from a serving point of view. If we are like, let's say even this becomes uh, same for cloud and the on-prem calls. So on a cloud, switching a session is basically we tried something with, let's say, Opus 4.8, it didn't work out. Now we like ask the same questions on Cablefy. Basically here we are switching sessions, but we are doing in a human way. So the entire cost that we spent on Opus 4.0 is kind of wasted. So now we're doing it with Fable, and Fable will take time to get the full context onto its model. So the caching is important. And same thing goes with on-prem. If there is uh, the entire repos uh, context cached on a particular model, it's better to use that model for those tasks and not to switch to different models uh, just because of a smaller gain. And yeah, so this does include the like route trace. So this is the modules one more like one more feature that it clearly has the trace of what it routed. So as we talked about, these are the 5 points. The router memory. The router memory is different from the semantic memory. The router memory is the high level, like the essential memory that router needs to make the hard decisions whether or not switch the model or not. If the last physical model is like it, we can have multiple uh, logics to route this. So if we are like on the last physical model for a long time, meaning we did use a lot of cache, and we need to see whether is it worth switching based on these session boundaries we have. Like if we are in a drifting stage, and even if KV cache is there, we don't mind switching because we are not getting any output there. And even if the like the idle time is lot and we want to use a different model, it doesn't make. So for all those decisions and to clarify, we need a memory set, a memory class in router itself, and that's the router memory. Uh, so hard logs are like whenever we are in a tool calling loop or any uh, hard logs which are specific to a model, it's not it's not optimal to switch to another model because the other model won't understand what this model is trying to do. So in those scenarios, we wouldn't be switching. Um, so again, the reset boundaries, we would allow the like switching after a drift or uh, after a like hard reselection or anything. And the economic space is like the like taking the cache locality and the prompt. I mean, some semantics on prompt would help us in the economics. And like the reply traces will give the idea of why we chose to switch, and this would give the full trace of the request lifespan. So yeah, that's all majorly this article covers. And so these ideas are really important in building a efficient router, which is good for a agentic system, not only good for a per prompt basis, but again highlighting the fact that for a single prompt, we are not taking all this caching, all the hard locking limits and everything else into account. So if it's purely based on semantics, it may not be the best, and it for sure for the agentic systems, it's not the best thing out there. So this kind of inevitable. So yeah, that's all. Maybe in future I'll be talking about the implementation of the same. Yeah, thank you.